Good morning, everyone. Today we are going to start the second chapter from Software Architecture and Design Patterns. Chapter name is Software Architecture. So, what is software architecture? Yes, software architecture. It is a structure or structure of a system or software system. Okay, it consists of software components. Some software components like some externally visible properties of those components, relationship between those components. Okay, it is a set of principle of design decisions that made about a software system. What kind of principle or what kind of design decisions like system structure, functional behavior of the system, interaction between modules, then non-functional properties, implementations, system goals. Okay, here, here you can see what is architecture or architectural thinking. Here, whenever user want to develop any software or any product, they are having some requirements. They want to implement those requirements, so we have to bridge the gap between that requirement and the solution for that requirement. Okay, so we have to bridge the gap between this users requirements and the implementation for that requirements. Okay, so how we can merge or how we can bridge that gap between that requirements and implementation? For that, we are going to use the software architecture. The role of software architecture here is we have to bridge the gap between that requirements and then implementations. Okay, so whenever user comes with that requirements, by using the software architecture, it consists of some system level design, some abstractions, some attributes. Okay, so it consists of some sdlcs, stlcs. By using that architecture, we are going to implement that requirements so that we can get the quality product. Okay, so that is the role of software architecture. So here, what is software architecture is or what it is not? Okay, so that software architecture is a program or a computing system is the structure or the structure of the system. Here the software architecture is, it is a program or it is a structure or it is a software structure of that system. Okay, structure of that software system, which comprises of some software elements, which comprises some software elements and the externally visible properties of those elements. The software elements like the requirements or the properties of that software. Okay, the components or the part of that software, that is the elements of that software. Then the properties of that elements. Okay, and the relationship between that elements of that software. So what is externally visible properties? Like the elements provide some services, the performance characteristics, the fault handling, and some shared resources or the usage of that shared resources. Okay, these are the externally visible properties of that elements. Okay, here software architecture is, it is a structure or the structure of the software system. Okay, which comprises or it is having some software elements or the components of that software, some externally visible properties and relationship between that elements. Okay, here elements means the modules of that software. Then here the implications of this definition. Here we have seen the definition of software architecture. Then what are the implications of this definition? So first one is architecture defines software elements. So architecture defines software elements means here how the elements are related to each other. Whenever we are going to define any or we are going to create any architecture for any system, they are having some software elements. So elements means modules or the components of that software. So the implication of this is architecture is how that elements are related to each other. Okay, or what are the abstraction of that system for that element. The next one is Systems comprises more than one structure. Multiple systems having here, suppose we are going to consider one system for like we are going to deploy or we are going to develop a software like uh, automatic or for example college system. So there are several structures are there. Okay, several architecture for yourself. So for example, we are going to consider system for college management system. Whenever we are going to develop the systems just like that, so every system having multiple architectures from multiple architectural perspective. Okay, there are software architecture is there. So that architecture is having multiple architectural styles for that software for that system. So we can say no one structure can claim to be the architecture. Okay, so whenever architecture is going to architect any system, so there are multiple structures or multiple architectures for one system, multiple architecture for a single system is there. So both that multiple architecture are independent or both are different from different perspective. Okay, so we cannot claim that architecture that this architecture told us the different way or that separate architecture is for separate system. Okay, so that architecture is not depend on any one perspective. So next one is relationship and elements. Okay, so that relationship and elements might be runtime related or non-runtime related. Okay, that runtime related means it will send the data or the processes to that system, or non-runtime related means it is submodel of or inherits from classes. These are the relationships. Okay, relationship between that elements, that is send data, submodel of or inherits from. These are the relationship between that elements. Okay, these are the runtime related relationship, and this is non-runtime related relationships. Okay, the first implication is architecture defines software elements, then system comprises more than one structure. Okay, the next one is every computing system with software has a software architecture. That means it does not necessarily to follow the architecture is known to anyone. We can create our own architecture for that system or that computing system. Or an architecture can exist independently of its description or specification. Based on that specification or the requirements from the end user or the customer, we are going to develop an architecture based on that specification. Okay, so there are multiple architectures will be there. Okay, so it is not necessary to follow the architecture that is known to everyone or anyone. It is not necessary that suppose customer having any architecture, we have to follow that architecture. It is not necessary. We can create our new architecture and we can follow that architecture. Okay, so next one is the behavior of each element is a part of architecture. So behavior of each element means it allows it allows elements to interact with each other. Every elements or the modules of that system can interact with each other by some uh, by their specifications. Okay, so we can add the specifications and properties to the elements and relationships. We can add some specifications and properties based on the requirements or based on that modules or elements, and based on that relationships we can add some specifications or add some extra requirements as per customer's view. Okay, these are the implications of the definitions of software architecture. Then who influences the software architecture? The influence of software architecture, the influence is based on the stakeholders of the system. Okay, here you can see the stakeholders can be these are the multiple stakeholders of the system. Here you can see the architect. Okay, this is the architecture of the system. This is the architect. This is the profile for that software development. Okay, this is the architect. These are the stakeholders of the system. Multiple stakeholders like development organizations, management stakeholder, marketing stakeholder, end user stakeholder, maintenance organization stakeholder, and customer stakeholder. Okay, these are the stakeholders of the system. Okay, those influences a software architecture. Okay, everyone having different perspective on their own. Okay, here you can see the development organization management stakeholder having or working on low cost, keeping people employed, leveraging existing corporate assets. Then marketing stakeholders, it needs features, short time to market, low cost, parity with competing products. Then end user stakeholder, it consists of the behavior, performance, security, and reliability of the system. Focuses on behavior, performance, and security of the system. Okay. Then maintenance organization stakeholder. It is the focus of this stakeholder is on modifiability. Okay. Then customer stakeholder. Customer wants the software in low cost, timely. They want timely delivery, not change very often. That means they don't want to change their once the software is deployed or once the customer gets the software, they don't want to change the software every time. Okay, it should be lifelong. So these are the stakeholders of the system who can influence or who can affect the software architecture. Okay, means suppose any stakeholder change their requirement at any time in SDLC, then architecture has to change based on that requirement. Okay, then why software architecture is important? So because the software architecture is important because it handles the complexity of the system. Means whenever we are going to develop any complex software, there are multiple complex task is there, multiple complex tasks are there. So to handle that complexity, we are going to create a model or we are going to create a prototype for that software. The architecturer will develop a model or design an architecture for that system so that we can understand or we can get the complexity of that system so that we can handle that complexity by using that architecture. We can easily understand how to do this task or how to perform several, how to design multiple modules. Okay, the next one is communication among stakeholders. We have seen the stakeholders here. Then how these stakeholders are going to communicate with each other. Then early design decisions. Then SA, that is software architecture is transferable, that is reusable model. So we will see this one by one. So there are fundamentally three reasons for software architecture is important from a technical perspective. Okay, so first one is communication among stakeholders. So we have seen the stakeholders, multiple stakeholders are there. So how they are communicating with each other. Okay, so that software architecture represents a common abstraction of a system that most, if not all of the system stakeholders can use as a basis of for mutual understanding, negotiations, consensus, and communication. They are communicating with each other by mutual understanding. Okay, so here you can see, so different stakeholders are there. Then their end user stakeholder and mark or the development organizations will communicate with each other by their, here you can see the end user or the customer will give the requirements to the development organizations. They are communicating by their mutual understanding. Okay, whenever they are satisfied, whenever the end user or the customer is satisfied with that organization based on their requirements, then only they are going to communicate for the next task. Okay, so this is by their mutual understanding they are going to communicate with each other. So this is the communication among stakeholders. Okay, the next one is early design decisions. So early design decisions means that software architecture manifests the earliest, that the software architecture manifests the earliest design decisions about a system with respect to system's remaining development, its deployment, and its maintenance life. Okay, here whenever we are going to deploy software to that customer, we have to take some decisions that is there any remaining part, is there any remaining development module is there, or its deployment, about its maintenance. Okay, their documentations, we have to take the decisions before the deployment of the software. Okay, that's why the software architecture is important here. Okay, the next one is transferable abstraction of system. transferable abstraction of a system. Here, software architecture model is transferable across systems. Okay, that means we are going to reuse some modules, their functional attributes or their functional requirements. So we are going to reuse that module. Okay, we are going to reuse that abstraction of that function. Okay, so suppose we have written one function for one task, like calculating area of anything. So okay, so we can use that function or use that abstraction into another system. Okay, that means reusability here. So we can transfer that abstraction of system. Okay, so these are some three reasons so that software architecture is important. Okay, so next one is architectural structure and views. Architectural structure and views. In last session, we have seen that 4+1 view model of software architecture. Okay, that consists of four views plus one. Okay, that is first one is logical view, process view, development view, and last one is implementation view. Okay, oh, sorry, physical view. Here you can see the logical view, implementation view, process view, and development view. And this is use case view. Okay, this is 4+1 view model, software architecture's 4+1 view model. Okay, here you can see the logical view consists of some functional requirements. Okay, it deals with design packages. Okay, here analysts and designers are there. Okay, they develop the structure or analyze the requirements, like functional and non-functional requirements, extensible requirements, normal requirements. Okay, they deals with the design of the system, design of the packages or subsystem or the classes or the layers of the system. The next view is implementation view. Here, this view deals mostly with programming and organization of the static software modules and testing. Okay. The next one is process view. We have seen that what is process view. Okay. The focus is on performance, scalability, concurrency, throughput. Okay. This will integrate the system. Okay, and measure the performance, scalability, concurrency, and throughput of the system by one by one. Okay, then next one is deployment view. In deployment view, this is the system engineering part. It consists of the delivery of system, installation, and communication of that system with the end user. Okay, last one is use case view. That is, these are the 4+1 view model of software architecture. Okay, then that use case view, this is the end user functionality. Here, by using use case view, we can understand the overall system. Okay, this is 4+1 view architecture of software architecture. Okay, here you can see the view. What is view? View is, it is complete description or abstraction of a system. Okay, here architectural structure and view, we have seen 4+1 view. Okay, so what is view? It is a representation of set of elements and the relations among them. Set of elements means modules or the components of that software architecture or the system. Okay, then structure, the set of elements itself. What are the structure is there? The structure of the system or the software or hardware part of that system. This is the structure, whole structure of that system. Okay, so everybody understood here?